of satellites, the standard deviation, and the minimum number of satellites available. This is of course zero, because when we are driving through tunnels, availability is zero, and the maximum. You see here the Trimble Peaks 982 has on the average availability of 12 satellites. This includes of course all of the 4 global navigation systems. For the U-Blocks receiver, which offers the possibility to deactivate single global navigation systems. For the first option, we have deactivated all the satellite systems except Galileo, so this is the availability in the second row of Galileo alone. It means we have on the average an availability of 4 satellites at that time on this test route. At another location, at another time, this may be different. The standard deviation for Galileo is 1. Minimum is of course also for the other option 0, and the maximum is 5. If we compare this with GPS, then you see the number of the average number of satellites with 7 is considerably higher. Standard deviation is also higher, and the maximum with 9 satellites is also higher. Of course, GPS is fully in operation, and Galileo not. If we combine Galileo and GPS, the average number of available satellites is again 12. The standard deviation is again a bit larger with 3, and we have a maximum number of satellites of 14. For the second test route, at another daytime, we have similar results. The test route is a bit shorter, therefore the number of measured positions is a bit lower, but you see here again, in the average, the available number of Galileo satellites are here 6. That means that is sufficient for reliable and accurate positioning. GPS is a bit higher, but actually that is more than is actually needed. Now you see here some examples from the native positioning. These are the positions mapped on the Google Earth pictures. This is an example from the route Stuttgart East area in Esslingen City. This is an example of a motorway. You see the blue positions are that of the Trimble together with the center point RTX means additional positioning services, and the other colors, green, blue, and yellow, are that from the U-Blocks receiver with different options, either Galileo and GPS together, or GPS and Galileo separate, without an additional positioning service. And you see here on this example, there is a very clear positioning on the route and on the road lane where the vehicle is actually driving. There's practically no significant difference. So consequence is current state of the art U-Blocks receiver, as a U-Blocks is able to achieve in most cases reliable position on the road lane. On the right picture, you see a part of the street that is within the Daimler Turkheim plant, which is a kind of a city canyon. And you see here that we have for GPS and center point a reliable position on the road, but we have a deviation, in this case for the U-Blocks with the Galileo satellites alone. And this is, of course, due to our test drive, this is an exception. Normally, we can say that we have a reliable and accurate position on the road lane, not more. Another examples are here from the Stuttgart city and the motorway. On the left motorway, you have here different road lanes. In the left example and in the example in the middle, you see here also again a clear position on the road lane. On the right picture, you see here an example from a rural road on a mountain in a curve, and also you see here as well, again, all options provide a position on the road lane. And these examples, these are not examples that are exceptions, but these are typical examples. The other examples where deviations are visible are, to our experience, exceptions. Another example using GNSS and the positioning service and the inertial measurement unit. This is the red line is the septentrion receiver with the positioning service SATO-SEPS. The yellow line is septentrion with the SPG measurement unit and the SATO-SEPS. And the blue one is the Trimble BX982 with positioning service center point RTX. You see here again the test route, the Stuttgart East area including Essling cities, and you see here 3 examples. We have a certain deviation between the positions of the different options, but again, it's clearly recognizable that we can identify the position on the road lane in, let's say, environments where there is not always clear sky. Now, the preliminary results for the vehicle positioning. The multi-GNSS receivers provide locally a sufficient number of satellites under difficult conditions with reliable positioning on road lanes. The Galileo satellites currently in operation improve reliable and accurate positioning, and the multi-GNSS receivers with additional positioning services provide positioning accuracy on a centimeter level. The routes with tunnels, which we have on our test routes, need our multi-GNSS receivers with an inertial measurement unit to have a continuous positioning also in tunnels. The preliminary resume of these results is that reliable positioning accuracy on decimeter level currently is only possible with positioning services. However, the future Galileo service with 20 centimeter accuracy closes the gap for applications which require decimeter accuracy, which we currently do not have. So, that's it. Thank you very much. I'm open for your questions.